Hey everyone, welcome. So, you're already building with SwiftUI, you know how powerful it is, but you're here because you're ready to move beyond the basics, right? You want to write cleaner, more scalable, and, truly dynamic UIs. Well, you're in the right place. Let's dive into 5 patterns that are going to help you do just that. We're going to start small with just a single reusable component. And then we'll build our way up, pattern by pattern, until we've got a fully responsive layout. Sound good? Let's get started.
All right, first up, the reusable building block. The foundation of any great SwiftUI app is getting away from repeating code and moving toward creating these self-contained, reusable components. Take a look at this. It's a simple profile card. Think of it as a self-contained piece of UI that knows one thing: how to display a name and a role. The cool part? It has absolutely no idea where that data comes from, and it doesn't need to. This is what makes it a pure, totally predictable view. So let's just break it down real quick. We define the component, we give it a couple of properties like name and role to catch the data we pass in, and then we just describe its layout inside the body. The key takeaway here, the big idea, is that this view is completely decoupled from any data source. And that's the goal, really. What we've created is basically a UI Lego brick. We can now snap this profile card into place anywhere in our app, and we can be totally confident it's going to look and work the exact same way, every single time. Okay, so we've got our Lego brick. Now for the next section, scaling with data. How do we take that one little component and use it to display a whole collection of information? Well, the answer is for each. This is where SwiftUI starts to feel kind of like magic. We're not sitting here creating profile cards by hand. Nope, we're just looping over an array of user data and generating a brand new profile card for each person in that list. The logic here is so simple, but it's incredibly powerful. Your data drives your UI. Simple as that. If you add a user to that array, poof, a new card appears on screen. You remove one, it vanishes. Your view becomes a direct mirror of your data model, which is exactly what we're aiming for if we want a clean architecture. Let's keep this train rolling. Section 3 is all about giving our components a purpose. So far, they just show data. What if we want them to actually do something? This is where we separate the view from its behavior. Now look closely at this action card. We're still passing in a string for the title, that's familiar. But notice that second property, on tap. That's not data. That's a closure. It's literally a function, an action, that we can pass into the view from the outside. This slide just lays it out perfectly. On the left, we're telling the view what to show. But on the right, with that closure, we're telling the view what to do. And that is a fundamental shift in how we build our components. So here's the crucial point. By passing in behavior, our action card becomes unbelievably versatile. One instance of it might save a profile, another might delete a file. The card itself, it doesn't care. It just knows it needs to execute whatever action it was handed, which makes it truly reusable in any context you can imagine. Okay, our components are now reusable, they're data-driven, and they're interactive. So let's move on to our 4th pattern and really bring them to life with some state-driven animations. The key, the absolute hero here, is the @state property wrapper. Is expanded as just a simple piece of state, a single source of truth that controls whether or not we see those extra details. So when the user taps, all we do is toggle that state, but we do it inside a with animation block. And it really is that simple. This 3-step process is the heart of almost every animation in SwiftUI. You define a piece of state, you change that state when something happens, and then you just tell SwiftUI, hey, animate the results of this change. And this is the best part. You don't have to mess with calculating frames or managing timing curves or any of that old school stuff. SwiftUI sees the state change. It figures out that the layout needs to update, and it just handles the smooth animation between the before and after. All for you. All right, we've covered components, data, actions, and animations. For our final section, let's zoom out and put it all together. Let's build layouts that look amazing on any screen size. Meet Lazy VGrid, one of SwiftUI's most powerful tools for building adaptive layouts. The secret sauce is right there in how we define the columns. We're not giving them fixed widths, we're just telling the grid, hey, I want 2 flexible columns. And that's the whole concept right there. Those flexible grid items will automatically share whatever space is available. So on an iPhone, they'll be narrower. On a big iPad, they'll expand to fill that wider screen. And all the content inside just adapts, all without you having to write a single line of device-specific code.
And that is what we mean by an adaptive layout. It's a UI that doesn't just get scaled up or down, it intelligently reflows and adjusts itself to be perfect for whatever device it happens to be running on. You can probably already see where this is useful, right? It's perfect for things like photo galleries, e-commerce product catalogs, or dashboards. Basically, anywhere you've got a collection of items that needs to look great on every possible screen. So let's do a quick recap. We started with that Lego brick reusable component. Then we learned how to populate it with data, how to give it purpose with actions, bring it to life with state-driven animations, and finally, arrange everything in a fully adaptive layout.
You see, each of these patterns builds on the last one to help you create truly professional, dynamic user interfaces. So the only question left is, when you think about your own projects, which one of these patterns are you going to implement first? Thanks so much for watching.